Uh, Hello everyone. Today we'll be starting with the second part, that is, we'll be studying here the uh, relationship between the bending moment, shear force, okay, and we'll be solving some problems, okay. So before going to the relationship and understanding the equations of the bending moment diagrams and shear force diagrams for the standard loading conditions, we'll first understand the basic requirements or the conditions for the drawing of shear force diagram and bending moment diagram. Okay, so what is shear force diagram? Shear force diagram is nothing but which shows the variation in the shear force along the length of the beam. Whatever might be the variations along the length of the beam, that variation is shown in the chart of in a frame of graphical presentations. That is called as shear force diagram. Okay, bending moment diagram is one which shows the variation of bending moment along the length of the beam. Okay, so this is what bending moment diagram is or shear force diagram is. Okay, we'll understand deeply once we understand the important points of drawing the shear force in the bending moment diagram, and when we solve the problems, and before that by try to derive some uh, equations, how to derive it. Once we'll try to know, we're not going deep of derivations, but we'll try to understand how to solve the problems in that way. Okay, so it will become both the ways. In that we'll understand how the shear force and bending moment are being drawn. Okay, the important points for the drawing of shear force and bending moment diagram. Consider the left or the right portion of the section while draw, solving the problem. Consider the right side or the left side of the beam where the section has been taken by you or um, by at the standard positions where we want the bending moment or the shear force to be find out, to be evaluated. Okay, these sections may be drawn at various circumstances for the same problems. If you want the section at A, you can take and then move it to the another point and take the section there and then find the bending moment and shear force diagram there. So the other left or the right of the sections you have to consider and you have to solve the problem. Next is add the forces normal to the beam, okay, on the one of the portions. So what you have to do is, in the shear force you have to add the upward vertical forces. That is, up forces means normal to the beam means which are perpendicular to the beam, okay, and that are vertical forces in the case of shear forces in or for the one portion. If you take a section, okay, if you take this as a beam, okay, cantilever beam, and this is your loading, okay, and you take, suppose this is A, this is B, this is C. Okay, first you take the section at BC. So if you consider left side or the right side, you have to take the values of the forces from that portion only. Okay, you can't shift the portions every time, that it is saying. Okay, next is positive value of shear force and the bending moment are plotted above the baseline of the baseline. Okay, there is a baseline to be drawn first. Okay, we'll understand what is a baseline, but just try to understand the important points. These important points you have to keep in mind while drawing the bending moment in the shear force diagram. So the positive values of shear force and bending moment should be drawn above the baseline, and the negative values should be below the baseline. Okay, next is the shear force diagram will be SFD means nothing but SFD, nothing means shear force diagram will increase or decrease suddenly by the vertical forces, by vertical straight lines at that sections. For that vertical load, consider this is a beam and it has a vertical load here. Okay, like this. So wherever there is a load, this is your baseline. So whenever there is a vertical load, you have to get down like this, or you have to get up like this. Okay, this is how you have to show this. This is your vertical line. Okay, vertical straight line. Okay, this line you have to show whenever there is a vertical load or vertical point load. Only when it is a point load you will be showing the straight fall or vertical rise. This is a rise, right? This is a fall. So the vertical rise or the vertical fall is sudden vertical fall or sudden vertical rise is shown only in the case of point loads. At the section where there is a point load, there will be a drop or the sudden rise in the graph. Okay. Next is shear force between the two vertical loads will be constant, and hence the shear force diagram between the two vertical loads will be horizontal. If you can see here in this same diagram, there are two loads, right? 1 and 2. Okay, so in between these two loads there is no loads. So from one point to the another point of the loading systems, there is no loading increase or decrease, it is constant. So it will remain in the horizontal line like this. When there are 2 point loads and in between them the load is not varying, so it will be constant, so it will be in the horizontal line. Okay, understanding what I'm saying? Hmm? Bending moment at a bending moment at that support, two supports of simply supported beam at a free ends of the cantilever and at a free end of the cantilever will be 0. That means if there is a cantilever, this is what is a beam. So bending moment at this section A and section B, that is at the support ends, at support A and support B will be 0. Okay, bending moment at the both the points will be 0. Keep it in the mind. No need to calculate it. The bending moment at the simply supported ends supports will be equal to 0. Okay, and the free end of the cantilever, it is the free end. This is your fixed end and this is your free end. Okay, the bending moment, if there is a load also, if there is no load also, shear force will be there, but the bending moment will be 0. So in the two cases the bending moment will be 0. The fixed it is, that is the ends of the simply supported beam and at the free end of the cantilever. Bending moment will be 0, not shear force, it is bending moment. Okay, so we'll try to understand how this calculation is to be done. Okay, you have to find the shear force in the bending moment diagram for the cantilever with a point load at the free end. You can see here a beam of length L. Okay, one end is fixed, one end is free, and the load, a point load of W is been placed at the point B, that is the free end. So how to calculate the shear force for this? So we have to calculate the shear force at two ends, that is at A and at one B. What is shear force? Shear force is nothing but the algebraic summation of the forces, right? So how many forces are there? there is only one force, it is W. So for to calculation of that, you have to take any section at any distance x, take a section. Okay, now suppose this is given in this diagram, that at the distance x, x section is taken. With respect to this x section, xx, okay, you have to calculate the shear force for that beam. This x is a now distance, and at this section xx we want the shear force. So what will be the shear force? Because it is, we have taken the section here, it is to the right hand side, this is a left, right? So right hand side downward force means what? It will be positive. If you consider upward and downward, it is positive. If the left side upward force is, it is positive, and right side downward forces will be positive. So what will be the force? It will be plus W, right, for the shear force at x. Okay, so shear force at A will be how much? Because there are no again any point load or any UDL load, it will remain constant, as it is said in the important points of drawing, that if there is a point load, then between the 2 point loads the load will be constant. So here there is no load only, there also the load will be constant only. So here also, because it is downward force and we have taken the section at the right hand side, okay, it is on the right hand side of the section, so the downward forces are positive, so it will be same only. Okay, understanding what I'm saying? So this is how you calculate the shear force at B and shear force at A is same, that is plus W, it is plus, don't forget to write plus. Okay, next, bending moment. How to calculate the bending moment? What is a formula to calculate the bending moment? It is load into the perpendicular distance, right? So for here also you have to take a section xx at a distance x on a beam. Okay, this, assume this is your section xx and a distance of x from the load. So if you see the, if you see here, the load is acting downwards, right, on the free end. So your beam will try to deflect like this. Okay, will try to deflect like this downwards. Okay, this is trying to make a sad face like this, right? You're applying a load here and it is trying to make a sad face, so it will be negative, that is hogging, right, as I said in the previous class. Okay, so the value will be negative. So first I will write bending moment at x. Okay, be first minus sign, then what is the formula? W into x, that is load into perpendicular distance, so W into x, right? So at what distance you want? So as per the uh, points, the bending moment at the free end of the cantilever will be 0, so moment at B will be 0 as per the given point. Okay, then we have to find the bending moment at A. So bending moment at A, okay, what is the formula? You have to use the same formula, but substitute x with respect to the total length of the beam, because the distance between the load to the A point is how much? L. So it will be minus W into L. Okay, this is your formula, right? W into L. Then how to draw? This is what is your shear force. Once you calculated shear force, you have to draw the bending moment diagram and shear force diagram. So we'll draw first the baseline like this. So the shear force was a positive plus W. So you have to go plus W here like this for a distance of W. It should be approximately, no to this, not to scale. Then it should be exactly below this beam. Okay, exactly at that point only it should start, where the point B is. This is W. Then it will be constant throughout, so it will pass like this till the point A. It will drop down with the plus sign here like this, and W here. Okay, this is what is your SFD for this problem. Okay, this is what your SFD. Now we will try to draw the BMT, this bending moment diagram. This is your bending moment diagram, baseline, sorry. Okay, for the baseline, if you see, the values are at B it is 0, and at A it is how much? Minus W into L. So minus means below the ground, below the baseline. So at the point it is 0, and it is point load. Okay, I will tell you, it is a point load. And when you are finding the bending moment, it should be inclined line, not rectangles. It should be a inclined line like this. So this, at this how much it is? Minus WL, right? This is how much? Minus WL. Now join this from here to here. Like this. Minus. Here it will be how much? 0. Here it will be minus WL. Right? This is how you are going to draw the bending moment diagram. If it is has UDL, then you will be having a parabola like this. If it is a point load, then you are going to draw a straight inclined line like this. That is the difference in drawing the bending moment. And if it is a point load, then shear force will be a rectangular shape. And if it is UDL, then it will be a inclined line here like this. Okay, for shear force, then it will be a like this parabola in bending moment for UDL case. Okay, this is how your comes, right? Same way I have shown here, plus sign. From B, this is a baseline. From base you have to mark W here, W, right? W. Okay, and then it is constant throughout the length, and bring it down there. Next is what? Your bending moment, right? It's a bending moment. It is W into, and those are the formulas you have to remember. Whatever I am telling it now, and we are calculating these shear force and bending moment, that is W, WL. You have to remember those things. I will make a chart and I will show you at the last. Okay, to how it is for different cases. Okay, now I will go for the next. See, here it is.